Hey guys, how's it going? My name is Professor Jennifer Hill, and this is Divide and Conquer Math, which is a website and YouTube channel dedicated to helping you learn math on your terms. And this video is part of my bigger series. It's a study series. So the purpose of videos like this are to give you practice problems to help you prepare for a calculus exam. And this is the first video in my integration series. So in this video, we're just going to look at kind of like basic integration problems to make sure that you kind of got the foundations there. So the way that these videos work, so like I said, this is just dedicated to giving you practice problems. Most of my channel is dedicated to helping you kind of learn the fundamentals or to give you lots of examples. But based off of conversations with my students, I also know that there's a need to just have straight up practice problems. And so that is what this series is about. It's not going to necessarily teach you, it's just going to give you stuff to practice. But if you are looking for ways to learn, don't worry, you could check out my website and the rest of my YouTube channel, and I have tons and tons of videos to help you kind of get those basics. So the way that these videos work, you'll want to look in the description of this video and you will see a link to the problem set. And so then what you're going to see is for the next hour, you will see me working on kind of my own stuff for about an hour. So that's just really a 1 hour timer to help get you motivated. So if you feel like you have trouble getting started with studying, consider using that 1 hour timer, I can't speak today, and just work alongside me. And then after an hour, after you've worked through that problem set, you will notice that the problem set also has a solution set as well. And so you can grade the problems that you have worked on, see what you got wrong. You can notice anything that you didn't know how to do. And then also in the description of this video, you will see time markers to every single problem, so you can just fast forward to any solutions that you want to see fully worked out. Now, if you realize that you also need to go back and review something, I do have links to videos that will help you review concepts if you're realizing that you've forgotten it. So the goal for these videos are to kind of be a one-stop shop to give you practice, but to also refer you to places to go review if you realize that you need that. Okay guys, so without further ado, why don't we start the problem set? Hey guys, I'm going to start going through the problem set, so if you're not done, you might want to hit pause here or start the study video over. So starting with number 1, so I just need to find the antiderivative here, and so I can do this by really using the antiderivative formulas, so you can pause the video if you need to. So the way that I think about this when I'm finding the antiderivative is, so I usually leave the coefficient alone, and just my thought process on this is first I figure out the exponent, so I need to add 1 to this. So if I add 1, that'll be 3. And then I take the reciprocal of this exponent and I multiply it by the whole problem. So the reciprocal of 3 is 1/3. So here's kind of all the things I need to get the antiderivative. And then don't forget about the plus c. So in the end, my antiderivative will be x cubed plus c. And then of course, you can really quickly check this by taking the derivative of this, which would indeed give me 3x squared. Okay, so for finding the antiderivative of sine of x, again, this is just an antiderivative formula, so you can see it right here. The confusing thing about this one is that the antiderivative is actually negative. That always throws people off when they're learning integration because the derivative of sine is positive, but the antiderivative of sine is negative. So if you struggle with that, just try to make like a set of note cards and really try to commit that to memory. Now, number 3 throws a lot of people off in terms of antiderivatives. I see this is like one of the most common types of antiderivatives people miss. So here, anything that's like a number over x, this is always going to be the natural log. This just throws people off all the time. It's definitely one of the most commonly missed problems. Again, making a set of note cards can really help you with that. Okay, so for number 4, to find the antiderivative of this, so I'm going to use a similar process of what I've used before. So I first carry that coefficient down. Now what I'm going to do is first figure out just what does the exponent need to be. So if I take -1/2 plus 1, this will be +1/2. And then I just multiply this by this whole thing by the reciprocal. So I'm going to multiply this by 2/1, and then don't forget about the plus c. So in the end, this will be x to the 1/2 plus c, or you could write the square root of x plus c, doesn't matter which form you want to put that in. For number 5, so I want to rewrite the cube root of x as x to the 1/3. And so now to find the antiderivative of that. So first things first, I want to take my x and I want to add 1 to the exponent. So this will be x to the 4/3, okay? And then in front of this, I'm going to multiply by the reciprocal. So the reciprocal of 4/3 is 3/4, and then that plus c. And so that would be my antiderivative in this case. Okay, so for number 6, I've got 3 secant 2x tangent 2x. So this might be a case where you want to like reference some of your antiderivative formulas. So basically like what that 2 is doing is it's telling us to create a like a coefficient to put out in front, okay? So this is the form of the antiderivative, and so just where I see that 2, I'm now going to put a 1/2 in front of my antiderivative. So this is going to be 3 times 1/2 secant 2x. So in the end, and then plus c. So this is 3/2 secant 2x plus c for my antiderivative. So for number 7, so now what we're going to use here is once again our antiderivative formulas. So I'm going to need both of these, and this is explaining what to do with those coefficients that go in the k place. So you can pause if you need to review those. So in this case, the antiderivative is going to be 1/3 positive sine of 3x plus pi of cosine x plus c. Now, I've brought this up before. The antiderivatives really throw people off because now you have to like switch the value of the signs. So just double check that you got your sign values right when you wrote this out. Okay, so for number 8, so I've got 1 minus 4/3x. So don't let this throw you off. So if you need to, you can rewrite this as 1/4/3 times 1/x. So this is the good old natural log that we need for this. So in this case, my antiderivative is going to be x minus 4/3 times the natural log of x plus c. And so that would be your antiderivative. Again, this is one of the most commonly missed antiderivatives when people first learn about this. So just keep that in mind. Okay, so for number 9 here, so I've got negative 2/3 x to the negative 2/5. There's a lot going on here. So for the antiderivative, I'm just going to write that coefficient of negative 2/3 down, and I'm going to forget about it. And the next thing that I'm going to do is I'm going to go ahead and add 1 to this exponent here, which is going to give me 3/5. And then I can multiply by the reciprocal. So the reciprocal would be 5/3, and then I can just kind of sort all of this out. So this becomes negative 10 over 9 x to the 3/5 plus c, and so there you go. Okay, so for x to the pi, so for the antiderivative of this, so I'm going to have x to the pi, so I'm just going to add 1 to that, and then I just put the reciprocal out in front, right? So the reciprocal of pi plus 1 would be 1 over pi plus 1. And so there you go. So for number 11, we're now going to just evaluate this integral, this indefinite integral. So really you're just finding your antiderivatives once again. So I will just show, so we're going to be using this, and we're going to also be using the natural log. So, okay, let's go back to that. All right, so finding the antiderivatives. So I've been talking about this. So if you're really unsure of how to do that, usually what I like to do is first I figure out the exponent, and then I multiply by the reciprocal like that. Then for this one, this is going to be 5 natural log of the absolute value of x. And then for this last one, this will be 5 times, okay, so first I figure out the exponent. So this will be x to the second, and then I multiply by the reciprocal. So there's kind of all the pieces that go into this, and then don't forget about the plus c. So in this case, my answer will be x cubed minus 5 natural log of x plus 5 over 2x squared plus c. So for 12, so once again, I'm just going to evaluate this indefinite integral. So this is going to be 2 times. So first I like to figure out what the exponent is going to be. So I add 1 to this. So this will be x to the 2/3. And then I multiply by the reciprocal. Don't forget about the plus c. So in the end, this becomes 3x to the 2/3 plus c. So for 13, so let's see. So I'm going to have 6 times. Let's see, this will be x to the 4th, so then I'll multiply this by 1/4, and then minus 2 times x to the 5th, and then I multiply this by 1/5, and then plus c. So this will end up becoming 3 over 2 x to the 4th minus 2/5 x to the 5th plus c. So for 14, so this one is meant to look a little tricky, and you need to do some simplifying before you finish this. So what I want to do is first I want to rewrite everything just in terms of rational exponents. And okay, so I've got all of this. Okay, and then I want to just simplify this as much as I can, okay? So this is going to be x to the 4/3 over x cubed minus x to the 1/2 over x to the 3rd, so dx. So in the end, what I'm really trying now to integrate is x to the negative 5/3 minus x to the negative 5/2. So I have really gone through and just simplified all of that. So now I can make some space. I'm going to make some space. All right, and so now let's integrate. So you know me, I like to first add 1 to my exponents. This will be to the negative 2/3, and then I multiply by the reciprocal like that. And then I'll do that again. So let's see, if I add 2 over 2, this will become negative 3 over 2, and then I can multiply by the reciprocal, negative 2/3, so this becomes a plus, and then I've got all that plus c. And so then, yeah, that is actually, that's it. So I could have, if I want to just write this in order, this would be 2/3 x to the
negative 3 halves minus 3 halves x to the negative 2/3 plus c. So that's just writing everything so that I have something positive coming first, but if you didn't write it like that, that's okay. Okay, so for number 15, so what I really need here is just to refer to my antiderivative formulas. So I've got this right here. So where I've got that k, I'm going to like turn that into a fraction in the front, so you can pause the video if you need to. Okay, so my antiderivative, I'm going to leave the 6 alone. I'm going to write 1 over 2 here, and then this will be negative cosine of 2x, all of that plus c. So I wrote this in parentheses so that I don't forget to kind of multiply these things together. So now this is going to be 3 cosine 2x plus c, and so there's my answer. Okay, so for number 16, so I've got cosecant x, cotangent x. So this is really just relying on us knowing our formulas. So cosecant and cotangent, so there's the formula, and so here's the form of the antiderivative. So in this case, this is just going to equal, nice and easy peasy, negative cosecant x plus c, and that's it. That's all we have to do for that one. Okay, so for number 17, so now I've got to take 1 plus cosine of 2x over 2. So, all right, the antiderivative of 1 is x. And then I'm going to take this 1/2 out here. And so now I'm going to take the antiderivative of cosine of 2x. So I know what I have to do from my formulas is I have to write 1 over 2, so 1 over this k part here. And then this will be sine of 2x plus c. So at the end of the day, this is x plus sine of 2x over 4 plus c. And so that would be my answer in that case. Okay, so for 18 here, so I've got 1 plus tangent squared x dx. All right, so the thing to notice about this, I want to just take a moment to think about what formulas we have available to us. So maybe I'll start here. So, okay, so I've got formulas for sine, cosine, and then here are all my other trig formulas. So notice there is no tangent squared on here, okay? So when that happens, that means then you have to use your noggin to figure out what else you can do. So when I think about this 1 plus tangent squared x, so this is actually one of like the trig properties. This is actually equal to secant squared. So if you don't have your trig properties memorized by this point in calculus, you've really got to get on it because these things pop up all the time. And okay, so now that I've gotten this written like that, I know that the antiderivative of secant squared is just tangent x. This is just tangent x plus c. So that's all you had to do for that one. Okay, so for 19 here, so I've got cosine of x times tangent x minus secant x. So we can't like take each one of these separate derivatives, okay, or sorry, antiderivatives. So you have to multiply this together. It's not like you can just take pieces of this. So if I go through and I try kind of multiplying this stuff together, so this is going to give me cosine of x, and I'm just going to rewrite tangent as sine of x over cosine of x, okay? And then I'm going to have cosine of x times, so secant is 1 over cosine of x. So here's actually kind of what I'm working with. So I have a lot of trig here that I can simplify. So in other words, these cosines will drop out, these cosines will drop out. So actually all I have to integrate in this case is going to be sine of x minus 1 dx. Now notice how I use parentheses here. Here I didn't need parentheses around the whole thing because this is like one term, right? These are all being multiplied together. But now that I've separated these are 2 terms, so I have parentheses around that. So that's just a little note on making your work look nice and neat. Okay, so this guy I can integrate no problem. So this is going to be negative cosine of x minus x plus c. And so there you go. Okay, so 20 is very similar to what we were doing with 18. So we do not have any way to integrate tangent squared x. So these are my antiderivative formulas. You can pause the video if you want. There's no tangent squared on this. So what you have to do then is you have to think back to what other formulas you have. And so the property here is that 1 plus secant squared x equals tangent, sorry, other way. My bad. 1 plus tangent squared x equals secant squared x. Okay, now I've got it right. Okay, so I can rewrite tangent squared then as secant squared x minus 1 dx. That is the only way I can really do this because I have an antiderivative formula for secant squared. I don't have one for tangent squared. You see how that works? So that's kind of what you're looking to do, is to get a problem like this to look like a formula that you can actually use. So this is going to be tangent x minus x plus c. So that'll be our the value of the integral. Okay, so now we've got to solve these initial value problems. So initial value problems, this is something that people often forget about. You have to use all the information given to you. So the way that the initial value problem works is first I just want to integrate this guy here. So if I integrate this, I have y is going to equal x squared minus 3x plus c. Okay, so this is my general solution because it's got the plus c, and what I'm trying to do is try to get rid of the c by using this information here. So now I have to use this information, and that's like how you know it's a initial value problem. It's got this other piece of information, so you should be asking yourself, did I use all the information, okay? So if I plug this in, this becomes 5 times negative 1 squared minus 3 times negative 1 plus c, and now bada bing, bada boom, I can just solve for c, right? So this becomes 5 equals 1 plus 3 plus c. So ultimately I will get that c equals 1. But wait, you have to finish this. So your answer here is x squared minus 3x plus 1. So make sure that you actually go through and write that out and make it like clear that that is the answer. Okay, so for number 22, so once again, I've got to integrate here. So another initial value problem. So I start by integrating this guy. So in integrating this is going to be 3 times, let's see, I always like to add 1 to the exponent first. So this will be x to the 1/3, and then I can multiply this by the reciprocal. So here's kind of like my general solution, or the structure of it. So this is going to equal then 9x to the 1/3 plus c. This is my general solution. Now I need to use this information here. So plugging all that in, this will be negative 4 equals 9 times negative 1 to the 1/3 plus c. And so then what I end up getting is negative 4 equals negative 9 plus c. And so then I'll get that c equals 5. So then my final answer here is 9x to the 1/3 plus 5. And so there's your answer. Okay, so moving on to 23 here. So now I've got 1/2 times the square root of x. Personally, I like to rewrite this as 1/2 x to the negative 1/2. It just makes it easier for me to integrate. So now if I'm trying to integrate this, so this is going to be 1/2 times, so you know I like to add 1 to the exponent first, and then I multiply by the reciprocal. And so my general solution is going to be just x to the 1/2 plus c. And so now I can plug in this information. So I've got 1 equals 4 to the 1/2 plus c. So this is going to indicate then that c equals negative 1, right? Because I take 1 minus the 2, because 4 to the 1/2 is 2. Okay, so there is my solution. So then, or there's my c. So then my final solution is that y equals the square root of x minus 1. So for number 24, we are given a second derivative. So we have actually 2 initial conditions to work with in this case. So let's get cracking here. So the first thing that you want to do is so integrate this, okay? So which will bring us not to now the function y, but instead y prime, right? Because we're given a second derivative. So, okay, I integrate this to get 2x minus 3/2x squared plus c. And so this is where this initial value condition comes in. Okay, so this is going to be 2 equals 2 times 0 minus 3/2 times 0 plus c, indicating that c equals 2. Okay, so now this is really now my dy dx, and so this is 2x minus 3/2 x squared plus 2. And so now I'm going to integrate again, and when I integrate this gives me y equals x squared minus 1/2 x cubed plus 2x plus c. Okay, and so now I'm going to use this initial value condition. So that's going to indicate then I get 3 equals 0 minus 0 plus 0 plus c. So that means that my c equals 3. So my final answer then, I'll write it in this gold color just to make it a little easier to read. This will be, let's see, I'll write it in descending order. So this will be negative 1/2 x cubed plus x squared plus 2x plus 3. And so there you go. So moving on to 25, so now we are working with definite integrals. So just dipping our toe in this a little bit. So what I'm going to do is I'm going to integrate this, so the antiderivative of sine x is negative cosine x, but now I have to bring in these limits of integration, and so now I just have to evaluate. So this will be negative cosine of pi over 3 minus negative cosine of 0. And so if I work all of that out, then I'm going to get that this is equal to, let's see, negative 1/2 plus 1, and so that ultimately equals 1/2. So for number 26, we've got this definite integral. So we're trying to integrate sine squared x, and the thing I want to point out, and like the thing you need to think about a lot when you are integrating, make sure you're not just plowing through it. Like, think about what it's asking you to do. So here's the thing. I have an antiderivative formula for sine, but not sine squared. Now, the only things that are like squared in my antiderivative formulas are like secant squared or cosecant squared. So we do not have sine squared. So what that tells me then is I have to use my noggin and figure out another way to integrate this. And you might think, oh, you know, maybe you think sine squared plus cosine squared x equals 1, but that doesn't really help because I still don't have an integration formula for cosine squared. So this will not work, so then we have to go back to the drawing board. So what else do we have? So the other formula that comes to mind would be the half angle formula. So this is another formula that if you don't have it memorized, it comes up a lot, I think, in calculus. And you might have to manipulate it, like when you look up half angle formula, a lot of times it comes up with the square root, but you can just square both sides to make this work. So anyways, this is probably the formula that we want. So what I'm gonna have to do is I'm gonna have to manipulate this problem so that I can use this formula, okay? So let me clear some space. And now I'm just gonna rewrite this. So now instead of this being sine squared x, this is going to become sine squared 2x over 2, because now I can bust out this formula. So this is going to equal now 1 minus cosine of 2x over 2 dx. And this is something I can integrate, okay? Because I can break this up into pieces now. So let's see, this will be 1/2 minus cosine of 2x over 2. This we can integrate no problem. So this is a pretty standard trick that you have to use with integration, honestly. All right, so if I integrate this, let me clear some space. So this is going to equal 1/2 x minus 1/2. So I'm taking out the 1/2 coefficient that was here, and then I'm going to multiply this by another coefficient of 1/2 sine of 2x. So all of this I need to evaluate from 0 to pi over 4. So let's see, this is going to become 1/2 x minus 1, actually let's write this as sine of 2x over 4. And okay, so now I can go ahead and start plugging stuff in. So this is going to give me 1/2 pi over 4 minus sine of, so when I put 2 times pi over 4, this becomes sine of pi over 2 over 4, and then this will be minus 0 minus sine of 0 over 4. Okay, so now working all of this out, let's see, I could use some more space. Okay, so let's finish this. So this is going to become pi over 8 minus 1 over 4. And yeah, that's it. I was gonna keep going, but then I realized the rest of that was 0. So that would be the answer in this case. So, and we could simplify that farther, but I think that's good enough. Okay, so for 27, so I've got now the definite integral from 1 to 125 of x to the negative 1/3. So first things first, let's go ahead and let's add 1 to the exponents. This becomes x to the 2/3, and then I multiply that by the reciprocal. And now I need to evaluate this from 1 to 125, so hopefully you remember your rational exponents. So I have 3 halves, and then this will be 125 to the 2/3 minus 3 halves, 1 to the 2/3. And so then let's see. The cube root of 125 is 5, and then 5 squared is 25. So then this will end up being 75, right? 25 times 3 is 75. So 75 over 2 minus 3 over 2. So this is going to give me 72 over 2, which ultimately equals 36. Okay, and so for our final problem here, so now I've got this definite integral from negative 2 to 3 x cubed minus x squared plus 2. So integrating this is going to be 1/4 x to the 4th minus 1/3 x cubed plus 2x. And now I want to integrate this from negative 2 to 3. So now I just plug stuff in. So this will be 3 to the 4th minus 1/3 3 cubed plus 2 times 3, all of that minus, let's see, I'll go down to this other line here, 1/4 times negative 2 to the 4th minus 1/3 negative 2 cubed plus 2 times negative 2. And let's see, okay, so I've got all that. So now this gives me 81 over 4 minus 27 over 3 plus 6 minus 16 over 4 plus 8 over 3 minus 4. Okay, so I need some more space. And then let's just write everything with a common denominator of 12, just so that we can finish the calculation. So this will be 243 over 12. This will be 108 over 12. This will be 72 over 12. This will be 48 over 12 minus 32 over 12, and then minus 48 over 12. So if, oh, this should be a plus. Okay, there we go. So now if I just work through on adding all the top pieces, so let's see, actually the 48s look like they drop out entirely. So now just finishing the math. This comes out to 175 over 12, or if you write that as a decimal, it's 14.583. And okay, that's it, we're done. So thanks for watching, guys. If you found this video helpful, consider leaving a comment or giving me a like. And otherwise, I'll catch you guys in the next video.